Well, hello again, sixth graders. Welcome as we continue our journey into the magical world of understanding data and all the different ways we can manipulate it. Yesterday we talked about box plots. Just to review that a little bit, you got a data set. You find the mean of that data set, then you go left and right of that data set, and you find the mean of those two quartiles. Once you determine what that is, you can build your box plot. Just to look at the vocabulary once again, you start out by finding the median, and then on each side of that median, you find again the median of those two sets of numbers, and that'll give you your upper and lower quartile. And the last thing you add is your least and greatest value. And there you have a box plot. Hopefully you didn't have too much trouble with that. I have a lot of confidence that you have figured this out. Just a reminder, if you really get stumped on one, don't be afraid to send me a text message and ask me to give you a little more explanation. I'll be happy to do that. Today, we're going to look at the mean, absolute deviation. Now, just within the terms of the lesson, we know what the mean is. The mean is the average. And what we're looking at is how much a set of numbers compared to another set of numbers that might have the same median can actually have a larger or smaller spread. So you don't want to get confused when you see, for example, on page 719, the first example they give you there, it's a couple of teams, and they each have a number of magazine subscriptions that they sold. And the median of those two groups, Team A and Team B, is 4. But when you look at the distance from the median, left and right of that, you can develop a greater sense of who has actually done more or who has done less. So let's just look at that one to begin with. We'll start with a number line there. And that's going to go from 0 to 10. Now, we've determined by looking at the data set, we have two sets, 3, 3, 4, 5, 5. So we got 3, 3, 4, 5, 5 in one group. We'll call that A. And then B, we've got 0, 1, 4, 7, 8. Now, when you look at these two sets of numbers, you see that 4 is indeed the median of those two sets of numbers. But they really tell two different stories. And that's why we go after the mean absolute deviation. And I'll show you how we get the average as we work through this. So the first thing you want to do is you want to look at your plot here. We've got a number line, and we're going to build a dot plot. Four is our median. So we're going to look at the set of numbers, and we're going to see that In group A, we've got 3, 3, 1 at 4, and 2 at 5. Now, here's what we begin to do. We're looking for the distance from the mean. So in this one, the distance from the mean to 3 is 1. And there are 2 of them, so we add another 1. The distance of this point is at the mean, so it's 0. It's no distance from it, it's right on it. The next is 5, and 5 again is 1 space to the right, and there are 2 of those. So, we've developed the deviation. 3 and 5 deviate from the mean 1 place. The one that is at 4 is at 0. So now let's put in our next set of numbers. And we're going to dot plot that as well. 0, we've got 1. 1, we've got 1. 4, we've got 1. So there's another 1 at 0. 7 and 8. Now you can see that's a completely different looking dot plot. So in order then to figure out how much each one of those dots deviate from the median, we just look. So at 0, it's 1, 2, 3, 4. So our first number will be 4. The 1 would be 1, 2, 3. 3 deviation points from the median. 7 is going to be 1, 2, 3. And then 8, one more space, would be 4. And don't forget, we have a 0 in here too, because we have a point right on 4. So now we've got 2 sets of numbers. Now this is where you find the average. You take each set of these numbers and you put it over top of how many there are. There are 5. Same thing with this one. Now, 1, 2, 0, 3, 4. This is going to equal 4 over 5. Here we've got 4, 7, 10, 14. So this is going to equal 14 over 5. And of course, when you have a fraction, essentially you have a division problem. So let's look at this. 4 divided by 5, your decimal point. So this is going to have a deviation of 0.8. 14 divided by 5. 5 goes into 14 twice. 10. 4, let's add a 0 here. This deviation then is 2.8. So you can see, regardless of the fact that both of them had a mean of 4, the distance in that set of data is much different, much smaller for group A than it is for group B. Does that make any sense? A lot of stuff to digest there. We'll look at one more problem. Let's go to page 720. And here they give you, under the Make Connection section, they give you a dot plot. And that dot plot, because you can find the mean absolute deviation for any set of numbers. And in this one, they start here at 8, and this one goes up to 14 on your number line, and it goes up in one number increments, so 9, 10, 11, 12, 13, just like that. And in their data, they have 1, 2, 3, 4 at 8, 1 at 9, 3 at 10, 3 at 12, 1 at 13. So there's our dot plot. Now let me read the problem. First of all, it says here, the mean is the distance of data values from the mean of the data set. It's called the absolute mean deviation. So the dot plot shows the ages of gymnasts registered for the school team. It tells you in the problem that the mean of the ages is 10. It's telling you that this is the mean of the ages. So find the mean absolute deviation of the data. Well, let's look at it. We've got 1, 2, 3, 4 that are 2 places. So that's 2, 2, and these are all plus, by the way. 2, 2. This is 1, so we're going to add 1. And this is 0. This is 0. And this is 0. And of course, we know zeros don't add any value, but we need the place. We need to know the total number of data points. So we put the zeros in, even though they don't have any value. At 12, which is 2 places, we've got 1, we've got 2, we've got 3. And then there's one more at 13, which would be 3 places. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 deviations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're going to take this whole thing, put it over 12. So now we've got 2, 4, 6, 8, 9, 11, 13, 15, 18. So we end up with 18 over 12. And now we just do the division. 18 divided by 12. 12 goes into 18 once. There's our 12. We got a 6. We're going to add a 0. 12 goes into 65 times. So our absolute mean deviation is 1.5. So the average distance from this point here is 1.5. So, and correct me if I've been calling this a median. I don't mean to call it a median. It's the mean. It's the average. It's not the median. It's not the middle point. Because if we were looking at the middle point of this set of numbers, we'd have to, the lowest number would be 8. The highest number would be 13. It would be 10.5 would be the median. So we're looking for the average of all those numbers added together and divided by however many numbers there are. So in order to get the mean deviation, once you've established that mean, you plug in all of your data points on a dot plot, and then you just record the distance they are from this mean. And again, it's one space. You're not recording the number 8 down here, you're recording the number of spaces it is. 1, 2. So that's a 2. That's a 2. That's a 2. That's a 2. This is a 1. Over here, this is a 2. This is a 2, and this is a 2, and this is a 3. These are all 0 because they are right at the mean. This is a little more confusing than it seems. You're just counting the distance from the mean in either direction, the number of places left and right. And then you're taking those numbers, lining them all up, and dividing them by the total number, which is giving you the mean deviation, the absolute. And in this particular case, on average, each one of these would be 1.5. 1.5 places to the left or 1.5 places to the right. Your homework is on page 723 and 724. But before I let you go, there's one more thing that caught my eye here. And I just got to remember where I saw it. On page 721. Number 4. Let me read that to you. The mean absolute deviation of the number of daily visits to Scott's website for February. Now it's giving you the mean deviation. Is 167.7. So February is 167.7. That's the absolute mean deviation that's been established for the month of February for them. In March, the absolute mean deviation was 235.9. In which month did the number of visits to Scott's website vary more? Explain how you know. So when you look at this, it varied more because the mean deviation was greater in March. In other words, it spread out more. So March would be the correct answer to that problem. The next part of this problem, number 5, says write an inequality. Now we all know what an inequality is, right? Less than, greater than, not equal to, or equal to. Number 5 says, write an inequality. In April, the data for Scott's website's visit are less spread out than they were in February. So April is less spread out than February. All right, let's see how this plays out here. Use A to represent a mean, so let's go A. There's our A. Let that represent, this is representative of the mean deviation for April. And it says write an inequality to describe the possible values of A. Well, we know by virtue of what it says here that it was less than they were in February. And what was the mean deviation in February? 167.7. So A is going to be less than 167.7. Did you follow that? Let me read it again. In April, the data for Scott's website visits are less spread out than they were in February. So we know April's going to be less than February. And it tells you to use A to represent April, and February is represented by this absolute mean deviation of 167.7. So this is how you would write your inequality. All right, go ahead and tackle into that stuff, wrestle around with it, get your homework, work through that on 723 and 24, and then tomorrow we'll take a look at measures of variability. How can you summarize a data set by using range, interquartile range, and the mean absolute deviation? So we've talked about range. We know range is the spread between the lowest and the greatest value. We know that we know what the interquartiles are. We also know what the mean absolute deviation is all about now. So we'll get into this measure of the different variabilities that can exist in a data set to further confuse all of you. Hang in there, keep the faith. We'll get through it. We are 6th graders, I think. Yes, we are in the last unit of our math book, so hang in there. We get through this, and we'll be done with your curriculum. And then we can look forward to playing math games for the rest of the year. Stay safe, stay out of trouble. We'll see you tomorrow.